Now let's look at the problem of finding the domain of a function from an equation. So the example would be pretty straightforward. It would simply find the domain of, let's say, g of x is equal to x squared minus 10x over x squared, let's say, plus 8x minus 20. So from an equation, here's the key. The key is there's three things that can't happen. There may be more, but usually if you focus on these three, you'll do fine. The key is, the first thing is you can't have a negative under the square root. It's actually an even root, but let's think about square roots first. So you can't have a negative under a square root. The second thing is you can't divide by 0. And the third step, which you may not use now, is that you can't have a log of a negative number. So when it says find the domain and it gives you an equation, these are really what they're asking you. Is there any place where that you would have a negative in the square root divided by 0 or log of a negative number? So the first thing we have to think about is we have to think about, let's look here, this function. This is a polynomial over a polynomial. Is there any problem with the numerator here? There's no roots and there's no log term, and it's in the numerator, so there's nothing wrong with that at all. Now let's look at the denominator here. The denominator, there's no square roots or logs, but it is in the denominator, so this can't be 0. So what can't happen is x squared plus 8x minus 20 cannot be equal to 0. So that's a domain restriction. So actually, the way that you solve for the domain is not by solving for the domain, but solving for all domain restrictions. So in order to solve where this is not equal to 0, you simply solve for it so it equals 0. And then what I do here is I'm either going to factor or use quadratic formula here. I think I can factor this. This is going to be a negative c, so it's a plus and a minus. So you get x plus x minus. What two numbers multiply to 20 and add to 8? Not 5 and 4, 10 and 2. It's 10 and 2. So this will be a positive 10 and a minus 2. X plus 10 is equal to 0, x minus 2 is equal to 0, x is minus 10, or x is positive 2. These are the restrictions, so what x cannot be is x cannot be equal to 10, and x cannot equal to a minus 10, and x cannot equal to a positive 2. So one way to write the domain here is simply all real numbers, x is not equal to minus 10, x is not equal to 2. If you want to write that in interval notation, it's a little bit more difficult. Let's focus on how we'd write that in interval notation. So let's just look at this. All real numbers, x is not 10 and 2, so let's graph that. That's going to be this entire line except for where there's a minus 10, there's going to be an open dot. And where there's a 2, there's going to be an open dot. So basically, not basically, it is going to be the case that this is going to be your graph. All of this, and all of this, with an open dot at 2 and an open dot at minus 10. So let's write the interval notation here. The first interval would be everything from minus infinity to minus 10, so that's minus infinity to minus 10. It doesn't include minus 10, so that's an open parentheses. With infinity, you always use open parentheses. Then it's going to include everything from minus 10 to 2, minus 10 to 2. Both of those are going to be open parentheses because it doesn't include either one. And then it's going to be everything from 2 to infinity. And this is going to be this, but also this, and also this, so it's an and, so it's going to be a union. So that's how you would write the domain in interval notation, and this is how you would write it in a simpler form. You don't need to know both, you just need to know which way to do it. Let's look at another example. Let's find the domain of square root of 3x minus 5 over, let's do 15x squared minus 20x. So again, what we're trying to do is we're really solving for the domain restrictions. What we can assume is what will be true is that the domain will be all real numbers except for whatever the restrictions are. And here's the restrictions. We want no negatives under the square root, and we can't divide by 0, and we can't take log of a negative number. The logs are actually done in a separate video, domain and range of logs, so we'll focus on the first two. So here's a root. So the root is such that this can't be negative. Can it be 0? Can you have square root of a negative? Can you have square root of 0? You can. So we know that 3x minus 5 has to be greater than or equal to 0. So then you're going to simply add 5 and add 5, and you get 3x is greater than or equal to 5. Divided by 3, x is greater than or equal to 5/3. So the first thing is x has to be greater than or equal to 5/3. That's because you can't have a negative under square root. The second thing you can't divide by 0, so 15x squared minus 20x is not equal to 0. So we solve where it's going to be equal to 0, and that's what it can't be. I'm going to factor a 5x here. If I factor a 5x there, I get 3x. Right, 5x, I get 3x minus 5/4. So that means 5x can't be 0, so x can't be 0. 3x minus 4 can't be 0. So then you add 4 and add 4. I'm going to come around here. 3x is not equal to 4. X is not equal to 4/3. So this gets fairly complicated. So let's look at our domain issues here. First, x has to be greater than or equal to 5/3. Also, x cannot be 0, and x cannot be 4/3. At this point, you probably want to graph it. So let's graph this. Let's draw a number line, because some of these may or may not be really important. Let's try this. 5/3. 5/3 is actually about 1.66 or so, right? 66 repeating. So let's plug that in. That's 5/3. It has to be greater than or equal to 5/3. So here's the first restriction. Close dot. Like that. It can't be 0. That's okay, not 0. That's not that important because we already know it's restricted here. And 4/3, this is about 1.6. It's actually 1.6 repeating. This is 1.3 repeating. So that's going to be right there, so that's fine. There's your domain. Your domain here is going to be x is greater than or equal to 5/3. And that's how you do domain and range of equations from graphs. The next one that we're going to do is we're just going to put a more right here and do some more examples. Remember, there's 3 key issues. You can't have negatives under the square root, and you can't divide by 0. You can't have log of a negative number. This is done with domain and range of logs.